So what do you do when the triangle is not a right triangle and you can't use SOHCAHTOA? Well, that's where the law of sines and the law of cosines come into play. The good news is that even though you probably have never heard of these laws, they're actually super easy to use. You just have to choose the correct rule to use. And the doubly good news is that if you know what SOHCAHTOA stands for, opposite over hypotenuse, adjacent over hypotenuse, etc., then these laws will actually make sense to you intuitively. Let's start with a triangle ABC, and let's label the angles big A, big B, and big C, and then we'll name the sides across for them little a, little b, and little c. So the law of sines has to do with the opposites, right? Sine of A over little a, which is the side length, equals sine of B over little b equals sine of C over little c. So if you're given a triangle and you know the angle measure of one angle and the length of the side opposite, you're probably working with the law of sines. But if you only have an angle and the sides adjacent to that angle, then you're probably working with the law of cosines, which is given by this equation. C squared equals A squared plus B squared minus 2 times AB times cosine of C. Now hang on, this looks a lot like the Pythagorean theorem, right? A squared plus B squared equals C squared. Well, when you have a 90-degree angle, the cosine of C is actually just equal to 0. And so this is the Pythagorean theorem, but it's just fancy because it's applied to a triangle that isn't a right triangle. Hang on, that's confusing. The law of cosines is just the fancy Pythagorean theorem? Yep, that's correct. C squared equals A squared plus B squared minus 2AB times cosine of C. And what this means is that when we're given an angle of a triangle and the sides adjacent to that angle, but not the side length opposite, we want to use this law of cosines, and we just plug in the numbers. Let's do an example. Triangle DEF has an angle measure F of 120 degrees, with the adjacent sides being 10 and 6. Side length D is 6 and side length E is 10. Now this is not a right triangle, so we can't just use the Pythagorean theorem, but we can use the fancy Pythagorean theorem, the law of cosines. C squared, which in this case is F squared is equal to 10 squared plus 6 squared minus 2 times 10 times 6 times the cosine of 120 degrees. We're just plugging in the numbers. So let's write this out. A squared, we can have 10 squared plus 6 squared minus 2 times 10 times 6 times the cosine of 120 degrees. That's 100 plus 36 minus 2 times 10 times 6, which is 120, times negative 0.5. So we have 100 plus 36 plus 60, because it's negative 1/2, and then we're subtracting a negative. So C squared is equal to 196. The square root of 196 is 14. The third side has a length of 14. Let's do another example. Pause this video and see if you can solve it before you watch my explanation. In a triangle, two sides measure 5 and 8, and the angle between them is 60 degrees. What is the length of the third side? All right, hopefully you paused this video and did the question. Notice that the two sides have the angle between them. That means we do not have the opposite sides from our angle, so we cannot use the law of sines. We have to use the law of cosines, that fancy Pythagorean theorem. C squared is equal to A squared plus B squared minus 2AB cosine of C, where C is that angle that we have. So C squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 60 degrees. Now that we've set up our equation, all we have to do is solve for C and we'll get the answer. So 5 squared is 25, 8 squared is 64, 25 plus 64 minus 2 times 5 times 8 times cosine of 60 degrees, which is 1/2, So that comes out to 40. 25 plus 64 minus 40 is 49. Square root of 49 is 7. C is equal to 7. And the third side has a length of 7. Now let's do a law of sines example questions. Pause this video, do the question, and come back to watch the explanation. In triangle ABC, angle A equals 30 degrees. Side A equals 10. Angle B equals 45 degrees. What is the length of side B? All right, hopefully you paused the video. Now we just set up our law of sines. Sine of A, so sine of 30 degrees over 10 is equal to sine of 45 degrees over B. Now all we have to do is solve for B. Sine of 30 degrees is 0.5 over A, which is 10. 0.5 over 10 is equal to sine of 45, which is about 0.707 over B. Solving for B, we multiply both sides by B, and 1/2 over 10 is just 0.05, so we divide both sides by 0.05. 0.707 divided by 0.05 is about 14, which is also 10 square roots of 2. So the answer is 14.14 or 10 square roots of 2. Same thing.